equipment. It could be a little more compact, take up less room in your basement. So you have more usable space in that basement than you might have with a normal AC system and heating system. You're going to have an improved aesthetic design because you're not going to have that outside unit sitting out there beside the deck with the fan blowing, and you're trying to sit on the deck and have a nice cold beverage, and you're hearing your air conditioner run, or you're hearing your neighbor's air conditioner running, that outside unit dumping heat out. Here, we don't have that outside unit. The outside unit component is that loop that's buried, okay? So that cuts down, of course, too, on wall penetrations. That cuts down on our vandalism factor, okay? You see, I worked on air conditioning units where they've needed replacement because, of course, somebody vandalized that piece of equipment in your yard, okay? Because it sits outside in your yard, that normal air conditioning unit, okay? As I stated, you're going to have that increased lifespan on your equipment because it's not working against those variations in ambient temperatures that your normal system has to work against. Heating, upwards of 400% efficient. Cooling, 300% efficient. So that geo-exchange system has great benefits to it. We have benefits. We're going to have, of course, disadvantages as well associated with that. Unfortunately, as I stated, you're going to have that higher initial installation cost with your geo-exchange system, okay? One of the things that people don't like about heat pumps is you have a lower supply air temperature, okay? The air coming out of your vents, out of your register, isn't the same air temperature that you have coming out of your forced air gas-fired furnace, right? Your gas-fired furnace, you have cold feet, you go stand on top of the register, get your toes all nice toasty warm. You're not going to have that same feeling from a heat pump system if it's dumping air into your space, okay? Because it's closer to your body temperature. You don't have that big temperature difference across there, which you have with that gas-fired appliance, that gas-fired furnace, okay? That was something that people feel are a little bit drafty, okay, in that regard. Of course, when a lot of the new systems for ground source heat pumps are being designed and they're heating the radiant floor system, an in-floor heating system, right? And an in-floor heating system does feel nice on your feet. It's nice, even, warm heat across the whole room. It's not that air passing over your body, okay? You're going to have increased airflow requirements, so in your heat pump system compared to your normal gas-fired or oil-fired furnace, okay? If I have a bigger temperature difference, means I can use less air. I can have smaller ductwork. I can have smaller airflow requirements. We're going to end up, maybe, if we design from scratch with a heat pump, we're going to have a bit bigger bigger ductwork in that system, okay? We're going to be moving a little bit more air. Again, that's why we might feel that it's cool. It's not cool because what are we trying to keep the room temperature at? Maybe we're trying to keep it at, in Fahrenheit, 75 degrees, 72, 75 degrees. In Celsius, 20, 22 degrees Celsius. The air coming out of the register is warmer than that room temperature requirement. But on a heat pump, it would typically be cooler than your body temperature, right? With your oil-fired or gas-fired appliance furnace, it's going to be warmer than your body temperature. Yep. One of the other disadvantages is there's landscaping cost around that loop installation. You're going to need, we'll talk about it, but you are going to need to do some function of landscaping. So that's an additional cost. Possible backup system needed. That's dependent on how your system design is. And of course, we're circulating an antifreeze solution. So again, we're circulating, as Rick stated, we're circulating a food grade, right? Which is non-toxic to me and you, right? But it is a antifreeze. It's not a water. It's not a pure water solution. So now if we do have a leak, is that, some people would feel, is that solution toxic to the insects, the bunny rabbits, the birds, right? There are going to be species that do have reactions if we happen to have a leak. Yeah, that's what I mean. Like it's the glycol is like I say, it's food grade, safe for me and you, but it's not necessarily safe for everybody else or other species. So of course that can become a disadvantage, right? Now with new technology, of course, is we have a lot better piping systems in terms of lifespan, and we're using better techniques for doing those joints, okay? A lot more durable. Here's some of the abbreviations you might run into when you're reading, if you're doing additional reading or you're seeing it in the newspaper. First one is GCHP, which is a ground-coupled heat pump system. This one, I've never worked on one, okay? This is where I'm actually putting the refrigerant into the ground. So that Freon is actually being pumped in the loop that's in the ground. Not a very typical system because that Freon or that refrigerant is very expensive cost-wise, okay? And we're now utilizing a large quantity of that refrigerant. Very efficient transfer though. I can make my loop a lot smaller if I could do this type of system. But that refrigerant cost is a lot higher, and then if I do have a leak, then I'm losing that solution. Next one, groundwater heat pump, GWHP. Okay, this is our typical system. The other name for it is just a GHP, which is our geothermal heat pump. You can also have your SWHP, which is your surface water heat pump. And we'll go through these in a minute here in terms of the differences. We can have an open loop or a closed loop system. An open loop system is typically surface water. So we have that pond, we have that lake, we have that river flowing beside us, beside our property. We take water off of there, or we even have an artesian well, say, or a well that we're not utilizing for potable water for our house. An open system takes that water, puts it through our heating system, or heating and air conditioning system, and then dumps the water. So we take, maybe if we're on the river, we take it upstream and we dump it downstream. Okay? In the lake, we take it from over here and we dump it over into the other part of the lake. It's a once through. That water's going once through our heating system. What that means, of course, is there's potential for contamination, right? More potential for fouling. There's, of course, with surface water, temperature's variation, right? We're going to freeze that surface water. That temperature is going to vary. It's not going to stay consistent. Typically, what we're seeing is closed loop ground systems. Greater flexibility in their usage, okay? But it does have a higher pumping capacity need because now we're pumping through that closed piping system. We have to overcome that friction in that pipe. Antifreeze is now required because we don't want that system to freeze up if we have a power failure and it stops pumping. And some of it is partially going to be exposed to areas where it might freeze, right? We don't want it to freeze there, burst our pipe, so we're going to end up with an antifreeze solution in it. We do end up now with a more stable design temperature, loop temperature. And we'll see a graph where you get to see how loops are affected, like